Hey everyone, and welcome to episode 3 of our Explainer. I am so pumped to have you all here today. Listen, if you're an offshore engineer or technician, especially if you're working on a 3-leg, 5-high inline EU configuration, this one is literally your blueprint. We are taking a super focused, step-by-step look at something absolutely vital to your day-to-day operations, the mandatory pre-jacking protocols for the Laterno Super 116E class rig. We're going to map out the entire critical electrical and control verification sequence so you know exactly what you're looking for, and more importantly, exactly why it matters. Now, you might be wondering, why go into so much detail? Well, the stakes absolutely couldn't be higher. We are talking about a jacking system that supports the immense weight of an entire offshore rig. Just think about that scale for a second. Pre-jacking checks? Yeah, they aren't just polite suggestions, they are your frontline defense. If a brake fails or, say, a ground fault goes undetected right at the start of jacking, the consequences can be, well, truly catastrophic. Skipping even a single step on these checklists is simply not an option. Okay, first things first, and I really want to establish absolute authority right out of the gate here. Document OP EU 375-700 Revision 04 explicitly states, consult your vessel-specific IOM manual before performing any work. Make no mistake, that manual is your Bible. Every single torque value, every clearance, every tiny lubricant specification, it's all dictated by that document. So while this explainer is going to guide you through the process and the concepts, your vessel-specific manual is the absolute ultimate authority on your rig's operating specs. Okay, let's dive into this. While a full pre-jacking protocol obviously includes brake testing, GFR checks, and oil levels, today we are zeroing in on the critical electrical triad, system energize, contactor tests, and finally, e-stop verification. All right, Phase 1, System Energize. Let's wake this rig up and bring the control system to life. You're going to start by actually turning that main key switch over to the on position. Next, keep your eyes on the touch screens as the HMI software begins to initialize and load. Actually, scratch that. Make sure you're watching both touch screens. But here is the absolutely critical visual confirmation you're waiting for. Those 3 stop push buttons must illuminate a bright, unmistakable red. Seeing those red lights? That's your definitive proof that the programmable logic controller, the PLC, is successfully communicating with your console. Without that red light, you are completely grounded. Up next is the incredibly crucial 10-second lamp test. Once your HMI is fully initialized, you're going to press the lamp test button. For exactly 10 seconds, every single console indicator and the alarm siren should fire off simultaneously. You are looking and you are listening. If that siren doesn't blare, or if even one single indicator light fails to light up during those 10 seconds, you stop. Right there. That specific circuit has to be hunted down and repaired before you can even think about moving forward. Moving right along to Section 2, Contactor Tests. We've proven the console is awake, but now we've got to prove the command signals for the leg movements are actually responding exactly the way they're supposed to. Listen, I am going to slow down my pace right here because this is literally life and death critical. Before you run any contactor test, you absolutely must visually verify that all 3 600-volt leg circuit breakers are open. Let me say that one more time for the folks in the back. Open. If you were to close a contactor with those circuit breakers closed and you didn't have an interlock, you would disastrously energize those massive motor circuits while testing. And that is incredibly, intensely dangerous. Open those breakers. Okay, so with the breakers safely open, you press Raise Hull for the bow leg. The contactor closes, you'll hear this loud, satisfying click, and the push button lights up. Cool? Then you hit Stop. Next, you press Lower Hull for that exact same leg. Now, both the raise and lower contactors have a mechanical interlock. And this brilliantly illustrates how the system literally protects itself. The interlock physically prevents both of them from closing at the same time. If you ever press a command and the contactor doesn't close, your very first move is to check that mechanical interlock. You'd be shocked how often a tiny bit of grime or just a stray zip tie is the actual culprit. Once you're clear, you repeat this entire sequence for the starboard and port legs. Finally, Section 3, E-stop verification. This is the ultimate defense mechanism, guys. Now, what's really interesting about this is the actual definition of the e-stop circuit itself. Notice it's a hardwired 24-volt DC circuit. So why does that matter? Well, because software glitches, right? Screens freeze, digital systems crash. But this emergency stop loop is a physical, hardwired break in the circuit. Software absolutely fundamentally cannot override a physical e-stop. When things hit the fan and you mash that button, it kills the power no matter what the computer is trying to do. 5. Exactly 5. That is the most important metric of this entire final test. There are exactly 5 distinct emergency stop locations on the Luterno Super 116E, and the protocol demands that every single one of them is verified. You can't just test 2 or 3, shrug, and assume the rest are fine. No way. All 5 demand rigorous testing every single time before jacking even begins. Let's actually walk through the physical footprint of the rig to find them. You start right where you already are, at the jacking console. Then you physically hike out to the bow leg platform. Next, you walk all the way over to the starboard leg platform. After that, you make your way across to the port leg platform. And finally, you head down to the jacking switchboard. You really need to visualize making that full trek around the rig, because that is exactly what this test demands in the real world. All right, so for each of those 5 locations, you're going to run a 2-part test. First, with one contactor closed and the breaker open, you press the e-stop. That contactor must immediately open. Easy enough? Once you've done that for all 5 locations, you reset. You go and close all 3 leg circuit breakers, and you go press each e-stop all over again. This time, all 3 breakers must trip open simultaneously. So the crucial point is this. Every single one of those 5 buttons must independently pass both of these tripping conditions. If even one e-stop fails to trip the circuit, it has to be flagged and repaired immediately before any jacking operations commence. Period. So, there you have it. We've covered the system energize, the contactor interlocks, and the hardwired e-stops. Once things are completely clear, you'd move right into checking your ground fault relays, testing your brakes, and confirming your oil levels. At the end of the day, your entire rig's safety relies on this specific sequence. So the question is, are you prepared to run it flawlessly every single time? Offshore engineering demands absolute precision. We never, ever cut corners. Thank you so much for joining me in this explainer, and hey, stay safe out there.